proteanTecs set out to revolutionize the way electronics are produced, especially high-end and more sophisticated electronics. If I were to characterize our first 2 years, it was bringing the technology to life. Actually, what we're doing is we're taking an opportunity to use the best of both worlds. We're a hardware company with respect to the fact that we embed what we call proteanTecs agents in silicon, which are very advanced monitors and elements that measure critical vitals of a chip at any stage in its life cycle. But the other end of our solution is our cloud-based SaaS, which actually receives this information and makes sense out of it, essentially providing actionable insights. So obviously our solution is relevant for many different sectors, but I'd like to focus on one single, specifically if you can imagine autonomous vehicles that are shortly going to be run by artificial intelligent chips. Imagine, if you will, this artificial intelligent chip that makes a decision that is life critical. For instance, it might decide if an airbag opens or the AWS system starts working. The tolerance for failure is nil. Nowadays, to overcome this risk, you might build into the car redundancy, or you might have different methodologies that overcompensate for failure. Again, once it fails, if it fails, finding out the reason for it is a lot of backtracking and finding if it's the chip or the system or the integrator. Using our technology, our unified chip telemetry, we actually plant agents in a chip that communicates throughout the life cycle. It doesn't matter if it's production or testing or integration or in the car itself. Using our unique ability to listen and provide visibility into the internal workings of the chip, we can effectively tell you that the chip will be failing, in fact, in 4 weeks from now. Truly predictive maintenance. And that would have been fine in itself. Pretty amazing, but beyond that, since our agent is alive also in production, we'll be able to say, we noticed an anomaly back in production, the chip was a little bit off. So we give an end-to-end full solution.